Thank you. Guten Abend, BASTA. 35 years ago, I took 2 years of German in college. I don't remember any of it. This is my first time in Germany. So let me first thank you. I very much appreciate the fact that your English is far superior to my German. So I can talk and you can mostly understand what it is that I need to say. The theme tonight of my talk is actually evolution. And I don't just mean evolution in the natural world, although we will get to some of that. Evolution also applies to human situations. Survival of the fittest works in our world. You are the fittest in the .NET environment. You have survived in that environment when many others did not survive. They're doing something else. You survived despite the fact that this environment is extremely complex. Anybody who could not deal with the complexity is gone doing something else. You are the survivors. Now, some of you do this. You survive the complexity because it's necessary to solve the problems you want to solve. But let us be honest. Some of you thrive on the complexity because you love it. Some of you are hardcore coders. You really like an environment that requires you to write a lot of code. In fact, some of you may have seen a video I did a few years ago. About halfway into the .NET era to where we are now, I noticed that there were a lot of people in the .NET environment that were addicted to writing code. It's like a drug to them. And of course those people survive in this environment. I can tell you whether or not you are one of them by taking the following simple test. If this has ever happened to you. If you have ever been, do you know the English term in the zone? It means you are concentrated. You know you are doing great work. So imagine sitting there and you have produced 200 or 300 or 400 lines of code, and it is some of the most wonderful work you've ever done, and then you push back from the keyboard and a shudder goes through your body. You think, oh, that's some good code. Okay? If that's ever happened to you, that's the sign of an addiction. So, I know that some people do it because they have to, but some do it because of that addiction. And so you are suited to the environment, even though you have that addiction, maybe even because of it. But evolution also tells us that what works in one environment might not work if the environment changes. For example, in a lush, swampy, warm world, these creatures did extremely well until their environment was changed. And then it was the hairy little mammals, our ancestors, that survived the new environment. So my first message to you, the fittest, the cream of the .NET world, is do not get too comfortable. Because what worked for you this year, what has enabled you to be as good as you are and as successful, might not be enough in 5 years, or maybe even in 2. Because in our world, the environment changes pretty fast. It can change because of new technologies. It can change because of competition coming in. In America, this is common. I don't know if it is here, but it's common for companies there to outsource, is the English word. Send their coding jobs to India or China or Bangladesh for 20 or 25% of what an American developer makes. Are we 5 times as good as those Indian developers? Gosh, I'd like to think so. I would. 10 times. I hope so. So technology changes. I'm going to talk about some of the technological changes and try to understand what the future is going to be like. Because, see, we're not like the dinosaurs. We're intelligent creatures. We can imagine the future, maybe even prepare for it if we use our reasoning powers. And if our predictions are right, we'll be prepared for it a lot better. So what's the future going to be like? Well, it's very hard to say. Look, if I were that good at predicting the future, I would have already made a fortune in the stock market, and I would not be here. I would be at home on a yacht or something. So I'm not the best future predictor, but I can see some things, especially if they're extremely obvious, by looking at big changes in the fairly recent past and trying to figure out where those changes might lead. So I'm from Nashville, Tennessee. We make a lot of music there. Now, 20 years ago, there were many, many large companies in the music business. They produced music, distributed music, the music labels, the music distribution companies. They were big and slow like those dinosaurs. They didn't see the future coming. This is the asteroid that destroyed them. They thought they were selling compact discs. No, their business was actually selling music. Now they're either gone or they're very small. But this little device was just the beginning. Apple then went and changed the whole phone universe with the iPhone. And then they introduced my teleprompter. The iPad. Oops, see, I did that, and now it switched the screen. Come on, there you go. What do all of these have in common? How are they changing the environment? All of these devices are based on a fundamental principle that is at odds with the .NET world. They are based on the concept of simplicity, the minimal number of features to get the job done. We are creatures of complexity. We are not well prepared for the changes that these devices bring. So, how many of you have an iPad? Some of you. So you've now seen touch devices. How many of you have written a production application that uses touch as the main interface? 1, 2, 3. Okay. How about? Oops, sorry, that's the wrong one. That's the wrong slide. In addition to the iPad, I don't know how that one got in there. Let me look at my slides because it looks like I've gotten. What happened to my picture of the Kinect? It's gone. Okay, I lost that slide somehow. I guess I'll talk about the Kinect then. In addition to the iDevices, iPod, iPhone, and iPad, another groundbreaking device is the Kinect. It was just announced, I think, that they will be making Kinect available for the .NET world to access. How many of you have written a gesture-based application? Oh gosh, that would be 0. So now we're looking at a trend of things that are changing your environment in a pretty dramatic way. What will that trend do? Well, to try to understand a little bit about the two ends of the trend, let's look at another similar trend and how things changed. This is an application that I created. Actually, it's from my memory what it looked like, because the machine I created it on in 1978, I'm sure there isn't a running machine anywhere in the world that would run my application. It was for temporary staffing. It was to manage temporary workers and match them up to jobs. In 1978, this was a major advance. Let me tell you, it beat file cards in a Rolodex and file folders, I mean real paper file folders, not computer file folders, in a filing cabinet. It beat it to pieces. But let me show you an application that by random chance, exactly 30 years later, I wrote another temporary staffing application. Let me spend about 2 minutes and show it to you. Well, I have to change my desktop. Now see, the basic idea is that Master Chief looks good in just about any desktop. But you have to move him, see. So, there we go. I'm telling you, he looks good in every desktop. I'll show you. Well, he looks really good on the ice. Watch this. My mouse is being a little funny. Let's do it with my touchpad. Put him right up here on the ice. There we go. He looks great, doesn't he? Let's start up my application. This application was written in 2008 by myself and a team of 2 other developers in about 8 or 9 months. It's got a dashboard with various interesting statistics that you might want to know about. You can click on those statistics to get details. Go back to that dashboard. You can have action items that you want to work on. You can click on them and they will go down and load the record all the way down to the place where that needs to be fixed. You can, there's various, that's the various open jobs. This is how you find a customer, if you want one. You can type in a Googlish kind of search. There's some customer with a Gmail address. See, where is it? See, Cheryl down here, I think, has a Gmail address there. We have various companies that are related to one another. We can see how they are related. If that's too big, we can scale it back a bit. We can edit individual customers. If we go to edit here, this is what the child editing screen looks like. We can drag it around and do things to it. But we don't have to fix it before we go on. We could go over to an employee, work on her for a while, go back. It will come back right where we left it. If I can manage to get my mouse click to work. There it is. We have sticky notes over here. They're editable. They collapse back out of the way when they're not needed. In employees, we have certainly the ability to set things like their skills. Pick a skill. Pick a level for the skill. It shows up over there. Okay. If we want to see a picture a little bit better, we can pop over it. Oh, that's where the button is to remove it too, if you decide you don't want it. Okay, so that's the temporary staffing application that we produced 30 years after the first one. Here's the quick comparison of them. That's the two ends of a trend. In 1978, the people who saw that thought it was amazing. It's not amazing anymore. But the people that saw this at the trade show that we introduced it, there were 15 other software systems that did the same thing, but they weren't very advanced over that. So what is this trend telling us? It says that we are moving from an era in which it's good enough to make something possible. We are moving to an era where that's not enough, where you have to make it easy. That's what the iPod, iPhone trend helps us see. That we are coming upon a generation of users who are not satisfied with possible. They expect easy. They expect natural. They expect beautiful. And we in the .NET world are, I believe, most of us, not ready for that world. Why do I say that? Well, it's because of the evolution in this world, the survival of the fittest. You got here because of writing the complex code. You didn't get here by designing intuitive interfaces. So we don't have very many people in this environment who know how to do that. In fact, you train your brain not to do that. You spend 8 hours in a day in an office or cubicle writing code. What does that mean? Well, if we look at the human brain, there are basically two categories of activities that it engages in. This is an oversimplification, but it will do. There are procedural, analytical, detailed tasks. Writing code is one of them. Those are called left brain tasks because they mostly take place in a normal right-handed person in the left brain. Then there are the tasks of understanding people, empathizing with them, seeing the big picture, appreciating beauty and aesthetics. Those are right-brained capabilities. You spend 8 hours a day sitting at your desk training your left brain. And I'm not criticizing that. That's your adaptation to today's environment. I just want you to be ready for a different environment that might be coming. Because you're never going to create this kind of application without using more of your right brain capabilities. Your trained left brain won't get you there. Now, a lot of people in the .NET world just want to delegate that to someone else. Find a designer to come in and do it. And I'm telling you, that doesn't work either. Designers don't know enough about the application and the domain and the data to do some of the things that need to be done. They're good at designing consumer applications. And companies like Apple have some of the finest designers in the world for their products. But your team probably can't find someone who can do this for you without you being involved. Okay, now, let me read your mind. There are people out there right now thinking, oh, Billy, I'm just no good at that right-brained, touchy-feely stuff. I'm a hardcore coder. I'm really good at that. By God, I'm going to keep doing that. You can't drag me into this black turtleneck stuff. I'm not buying that for a minute. Okay, who's thinking that? Come on, see the hands. It's all right. You can admit it. See, we've got at least one back there. And I think a lot more of you are thinking that, and you're just not saying it. Well, you know, some of you are probably right. You might not be good at these things, and that's okay because we're going to need pure coders still, maybe, for a while. I mean, you know, as environments change, it's a complex thing. I mean, some scientists believe that the dinosaurs never really went away when their environment changed. They believe the dinosaurs just changed into birds. So maybe you're right that, you know, you wouldn't be any good at that, but I don't think you should jump to conclusions about it. Because if you think you can't do it because your right brain just doesn't work, I really think you're wrong about that. Everyone in here has a right brain that works. I can prove it to you. So I'm the cook in our house. I usually cook breakfast, most commonly bacon and eggs. I'm going to go on a tour of Europe someday because as much as I love many things about Europe, no one here knows how to cook bacon. So I'll come and show you. So I cook bacon and eggs, and I usually get the eggs out and I put them beside the pan while the bacon's cooking. And one day, I decided to take a picture of the eggs waiting beside the pan of bacon. Here's the picture. Now, why did you laugh at that? Do you think that there's a part of your left brain that ran an algorithm? There are 2 eggs. They have faces. The faces look scared. There is bacon in a hot pan. Ha ha ha. No. You grasped the entire situation and found it humorous. Almost all humor is right-brained. If you have a sense of humor, your right brain is working. I hope most of you do. If you can recognize your spouse or girlfriend or boyfriend in a crowded room of people, your left brain does not know how to recognize faces. It doesn't know how to do it. Your right brain does that. So please don't try to give me this, my right brain just doesn't work excuse, because that's not true. The problem is you don't exercise it. You exercise your left brain all the time. Imagine that you went to lift weights hours a day, but you only lifted weights with the right arm. I mean, you have a perfectly good reason. If you're like me, I'm right-handed. My right arm works well. My left arm doesn't work nearly as well. Why bother to work on it? Why bother to exercise it? What would you look like after a year or two of lifting weights with just one arm? Big muscles here, and this one's kind of hanging down, atrophied. You might be able to pick up a pencil, but look, there are reasons I need both arms. This one might work better for most things, but if I'm typing, I need them both. If I'm going to lift this table, I need them both, and I need this one to have some strength. If we're going to work in this new world, we need both sides of our brain. We need both of them engaged and working. So for the time I have left, I'd like to talk to you a little bit about how to train that other side of your brain. And it starts with observation. There is a test, and I'm going to have you take this test. It's a video to watch. Some of you may have seen this test. If you have, I require you to be absolutely quiet and not give the answer away to those who have not seen it. The test involves 2 teams playing basketball. One of them is dressed in white, and one of them is dressed in black. See, he's seen it, haven't you? You must be quiet. Who has seen that test? Okay, who has not seen this test? Most of the group. Those of you who have seen it must be absolutely quiet and not give the answer away. Your task is to count the number of times someone on the white team passes the basketball to someone else, throws it or bounces it. That's all. It's going to require focus now, okay? To see every pass and count them accurately. We'll see how good your observation is. Now, it is possible that I have planted people in the audience to mislead you. So be sure of when I ask you the results at the end that you know what you believe about the answers, because I may have people who will attempt to mislead you. You ready? Okay. Okay, here is the test.
This is an awareness test. How many passes does the team in white make?
Go!
How many passes? So you can't even agree, even though you all said 17. Well, we'll see the answer in a moment, but I have another question before we go on to that. Was there anything you noticed about that video unusual that you weren't expecting? No? Yes? I'm sorry, translation, someone? The black. Yes? I'm not sure I understand your question. Not red or... Did I say black? Did I say red? I thought I should have been black. It's black and red. I may have misstated. I thought I said black. Okay, anything else? I'm sorry? 2 balls, yeah, for each team. You didn't notice anything about that video unusual? Yes? They kept mixing it up, yes. Well, let's watch the end of the test and see what you think. So.
The answer is 13. But did you see the moonwalking bear?
Go!
If I ask you a question, will you be completely honest with me? How many of you did not see the bear the first time? The brain is a mysterious thing. Let's do another test. I'm going to break you into the right brain side of things. Here is an elevator panel. I took this picture at a hotel in New Orleans, Louisiana, last summer. I would like you to see if there is anything about this elevator panel you find notable. That is, if you got on the elevator with someone, that you might point it out to them. Okay, just let's take a few seconds. What I'd like you to do is, if you see something notable, please put your hand up. I'll give you a few seconds. Okay, so what did you see? 413 is missing. That's common, actually, in America, but that is a classic left-brained analysis point. And the majority of developers will usually notice that first. That is not what I noticed, and it is not why I took the picture. Yes? Yes, the first level. Did you notice the paint smeared off? Why is the paint smeared off? It's the most used button. Well, yes, but this is not an elevator button. This is a metal circle. This is the button. But the paint is worn off because people are pressing the metal piece. Why? Because it looks like a button. Buttons have been round for hundreds of years. And if they just glance quickly, they see that. Now, this is bad design. And when you begin to engage your right brain, you start to see bad design. This is better design. This is the elevator at Mandalay Bay in Las Vegas. It's an interesting hotel. It's a luxury hotel. It is the only luxury hotel I've ever been in where the video that plays in the elevator with advertisements, it played an advertisement for a tattoo parlor that was located in the lobby of the hotel. Anyway, notice this buttons. The design here. Now, the metal piece is not round. It has this shape to it. And it includes a slot for the button to fit into. That is good design. Plus the fact that the most used buttons are bigger, easier to find, faster to get to. Now, how do these How do these principles transfer over to software? Well, I've created this, but I created it based on a software program I saw a few months ago. I went to a trade show for a client to look at lots of brands of medical software for working with x-rays and related things. Several of them looked about like this because that software has a lot of functions. So most of them had some huge block of buttons with completely random icons on them. There wasn't anything about the icons that helped. Well, this violates good design principles, just like the elevator panel did. First of all, it violates something called the 80-20 rule, or the Pareto principle, which says that probably 20% of those buttons are used 80% of the time. That's likely. That's a good general principle, that 20% of the data in your systems has 80% of the value. 20% of your users give you 80% of your problems. Maybe it's 10-90. It's hard to say. So some of those buttons are much more important than the others. Why don't we take the buttons that aren't used so much and put them somewhere else under an advanced section? Plus, there's Fitts' law. The amount of time required to locate and use an option is less if the option is bigger. Remember the elevators with the big buttons? There is no law, at least there in the United States there is, and I don't think the EU has passed one yet, that all buttons have to be the same size. There's no law about that. So we could make the buttons that are frequently used bigger, and it would be faster for the users to find and use them. Then there is Hicks' law. The amount of time required to locate and use an option is larger if the user must choose from many options. There's research backing all of this up. What that means is every time you add an option to your software, you make the other functions less valuable because they are harder to locate and use. In the .NET world, we love complexity. We're perfectly happy to write code for that feature the user wants without thinking about the fact that it makes the rest of our applications less valuable. That's the kind of thinking I want you to begin to engage if you're going to engage your right brain and maybe be ready for this changing environment. But if you're going to do better, you have to understand more. You have to understand what the user does. You have to get inside their minds. You have to be able to think like them. Now, that is a right brain skill. You don't get that by analysis. Left brain developers generally don't want to do that because, I'll be honest, I think for a lot of people in the .NET world, when it comes to right brain tasks, they just avoid them from laziness, I guess, or something. They just would prefer to put a bunch of buttons on there and let the users figure it out. In other words, they prefer to think that if they've made something possible, that's good enough. And I believe we are leaving that world into which we have a responsibility to make it easy. Are there other design principles? Sure, there's tons of them. You'll understand them better, in many cases, if you understand evolution. So, for example, there's the principle of white space. What do you think about this screen? Boy, it's got a lot of stuff on it, doesn't it? Crowded, busy, we say in America. Too much information. Why don't you like it? Well, first of all, let's talk about the fact this was done by Microsoft Consulting Services in Great Britain as a prototype for the National Health Service. And I think it's bad design. Even though there are a couple of pieces that aren't too bad, the overall effect is just not good design. Certainly, compared to this feels much more open, right? Why does this feel better? Because of the way our brains work as they were shaped by evolution. It's called the Savanna Principle. You know the English word savanna? Open fields in Africa. So people came down. Is that the same in German, I guess? So people came down from trees to live on savanna 30,000, 40,000 years ago. Now, put yourself in the mind of your ancestor 30,000 years ago on the savanna. And you see the open field, and there are two trees and a bush. And that's all you see. What does that mean to you? It means that you are safe. You can keep your eye on all three of them, and nothing's going to surprise you. Now suppose you are in a location where there are trees all around you, and a lion might jump out from behind any one of them. Now you're stressed. You don't like it. You feel uncomfortable. The brain prefers openness. It draws comfort from openness. So, when we designed this screen, this is a tab control. Those are tabs. But we took all those silly lines and boxes away. They aren't needed. We don't use left justified labels. We make them right justified. It preserves more white space. White space makes people feel more comfortable, less stressful. Here's another principle. Oops, yeah, I guess I should. I forgot I had these two pictures. So to kind of see the Savanna Principle in action yourself, I have two pictures for you. You decide which one makes you feel calm and which one makes you feel tense. This one or this one? Your brain is hardwired to prefer this. I'll tell you about another principle. You saw me demonstrate an application just a few moments ago. It had the expandable notes. I want you to answer a question for me very quickly, please. What color were those notes? Were they? Let's look at them again. They actually were not yellow. They are a gradient that goes from light on the top to darker on the bottom in various shades. You didn't notice that first, did you? You didn't even see it. You didn't see it any more than you saw the bear. Did you notice that the editing screen has a gradient? Starts up there, comes down. Not only is it a gradient, it's lighter on the top, both of them. Why? Because in the real world, first of all, there is no monochrome. Our brains believe that monochrome is artificial because all they see is monochrome on computer screens and manufactured things. In the real world, everything is gradients. Even if you paint a wall the same color, lighting effects will make it look like a gradient. If I put a Post-it note on my desk like that, it will probably have a little gradient on it. So your brain is hardwired to believe that gradient colors are natural and monochrome colors are artificial. It has also evolved to prefer lighter gradients on top. Why? Because that's where the light comes from in the real world. That feels natural. Have you ever seen the picture of someone holding a flashlight underneath their face, shining up on their face? And it looks creepy. Because our brains don't expect light to come from underneath. So understanding how brains are wired and the evolutionary consequences can help us remember these design principles and apply them. Animation is another example where it's more natural if did you notice when I went over this, it doesn't just jump bigger, It grows bigger. Because in the real world, things don't suddenly get bigger. If I was here and then I'm there in the blink of an eye, that's scary. That's tense. Things don't disappear here and reappear there in the real world. So the brain prefers things to change smoothly. There are other design principles at work. Let's go back to my slides. Is there anyone here from the class that I did this week? I think that, yeah, okay, good. I need you to back me up on something in just a moment. So I'm running later than I would like to be. So, this is the way we might do things with our current .NET way of thinking. We need a card view for a student. We would probably lay it out something like this. Well, I guess that's it's horrible, but what if I did it like this instead? We have software now that will let us do this, that will let us create layers with 3D effects to make the image feel more natural, the text not be so jarring. And you probably look at that and think, gosh, that would take so long to do. How long did it take me in class to move from this to this? Well, I think it was more like 20 seconds, but 30 seconds, but it wasn't very long. What's good about this? Well, it uses less space, but probably the first thing you notice is it's more appealing, it's more attractive, it's more beautiful. Is that important? Yes. Yes, it is. They even have a design principle about that called the aesthetic usability effect. It means that if people see beautiful software, they believe it works better, even if it doesn't. Even if the functionality is no better than other software, if it's beautiful, they think it works better. Well, why should we expect them to be any other way? In the real world, how long do people take to make up an impression when they meet someone? Have you seen the studies? The first 20 seconds, they decide what they think about that person. What do they base that on? Mostly appearance. An attractive person gets more chances to prove themselves. And it's just a natural thing. Evolutionarily, we prefer attractive people. We can't help it. They don't put ugly people on magazine covers. They wouldn't sell if they did. They even airbrush them to make them prettier. Sometimes they go too far and make them unnatural. So if software is beautiful, users will like it more, and that makes them more productive. And there are just dozens of these design principles. Most of them are pretty easily explained by that evolution of the brain. And if you want to get an overview of them, this is a pretty good book to try. It explains 125 design principles. One page for each one, with one other page showing examples. Not all of them apply to software, but about 3/4 of them do. What else can you do to exercise your right brain? Well, you can look at examples of good design and bad design. I talked about the elevators. You can carry, I carried for about 8 or 9 months, a design notebook. And when I found a good design, I would sketch it. If I found a bad design, I would sketch it. That helped me remember the principles that were involved. In fact, sketching itself is a really good way to exercise your right brain. And this is a good book to learn to sketch and draw if you've never done it. I've had friends say that this book changed their life after I recommended it to them. It lights up a part of the brain that some people in this complex left brain .NET world really don't use very much. Now, I got other suggestions I was going to make. Music. I live in Nashville. Musicians, I think, seem to, in my experience, make better developers. I think because they train up their right brain. But you know, there's somebody in this sitting in the audience. Here's the mind reading. Oh, Billy, that sounds good, but we're just too busy. We don't have time for this, that touchy-feely stuff. Who's going to pay for it? Besides, I have code to write. Well, let's do some math. Suppose my system has 1,000 users, and suppose I can use these principles and my new design sensibilities to make them 10% more productive. Now, we have had situations where we made users 40 to 50% more productive, measured with metrics in the company. So 10% isn't that hard. So you have 1,000 people. You make them 10% more productive. You have now just contributed 100 free people to your organization. How much does a person make in Germany? How many euros a year, including their parking and, on average, their desk, their salary, their benefits, everything? How many euros? 80,000 loaded? I was going to say 60, but I don't have 80,000 loaded. That's about right because in America it's over 100. 80,000 loaded. 80,000 times 100 is, come on, you geeks, 8 million euros a year if you can make 1,000 people 10% more productive. So yes, there's money to be done. There's money to be had in this world. And you know, don't forget, when the environment changes, you might not have a choice. As I said, we have an entire generation that are coming into their 20s who grew up on iPod and iPhone, and it's just not enough for them for something to be possible. They expect it to be easy. If you expect to please them and continue to be valued to them, you need to learn to make things easy, to master complexity, and to simplify it. And to do that, you'll need both sides of your brain. You still need to analyze. You still need to write code. That part will not go away. But you also need to empathize with your users. Understand these design principles so that you don't make obvious mistakes. I entered this world a few years ago. Today, I turn away more business than I take because there is such a shortage of people who do what I do. Some of you have the talent to do what I do. And let me tell you, my consulting rates, I jokingly call them extortionate. You know that English word? Extortion? It means taking something from somebody at the point of a gun. They're high. My consulting rates are very high, and I turn business away because there is tremendous demand in this world. But to play in that world, you must be whole-brain developers. I hope that some of you will be among them, and I hope that tonight may have helped you see maybe what that path is going to be. If you'd like to contact me, find out anything, go to billyhollis.com. It will actually redirect somewhere else. You must have Silverlight loaded because my website's in Silverlight. And it has gradient fills. And nice animation, too, even though I wrote it 3 years ago. You've been a wonderful audience, and I appreciate you listening to me. I will be here to answer questions for a while as I tear down. Thank you so much, and I hope this has been a wonderful conference for you.